Now let's learn about how to write Nernst equation and also the calculation. Okay, number one, let's learn how to write the Nernst equation. Okay, first of all, to write the Nernst equation, you need to balance the equation. Okay, you need to know the overall cell equation. Okay, then this part is reactant. This part is the product. Okay, now this is the Nernst equation, but if you just give general, that is product over reactant, you will not get any marks. Okay, then another marks will be given for number of electron. Number of electron, you need to balance the anode and cathode half cell equation. Only then you know what is the number of electron. Okay, now we go to the product and the reactant. Most students tend to ignore the pressure, especially when it comes to gas, because sometimes the information given is 1 atm. Okay, so when it is 1 atm, you still need to substitute into the Nernst equation. Another one is the coefficient. Students also tend to left out the coefficient. Then another one, if it's solid and liquid, then you don't have to include into the Nernst equation. Okay, now we continue with calculation part. Determine cell potential, concentration or partial pressure. Another one is the equilibrium constant. Okay, now let's look at what we have here. Okay, a voltaic cell consists of cadmium electrode and standard hydrogen electrode. Electron flows from cadmium electrode to platinum electrode. Okay, so from this one, we know that cadmium is anode, and then platinum electrode. Okay, where this platinum electrode comes from? It comes from the standard hydrogen electrode. Okay, so this is what we've got. Okay, and then says that calculates the cell voltage. Okay, you can see here, this is 1.5 molar. It is not at standard condition, 1 molar. Okay, so the cell voltage that we are calculating will be E cell. Okay, so before we substitute into the Nernst equation, we need to get the balanced overall cell equation because we want to see if there's any coefficient. Another one is we need to determine the product and the reactant and also the phase. Okay, solid means we are not going to inside. So we only have 3 species, aqueous, and gas. Okay, so we can start to write now. So E cell equals to E naught cell minus 0.0592, okay, over n. Okay, what is our number of electron? 2. Okay, then log, what is our product? Gas. Another one, aqueous. Okay, but we don't have any coefficient here. So we look at hydrogen, is the reactant. So it's H plus. And remember the coefficient is 2. Okay, so then finally you will get the answer equals to positive 0.394 volts. Okay, I'm just here to teach. In this video, I'm just going to focus on how to write the Nernst equation. Okay, now another one. We can find now, we have focused how to find the E cell because it's already given us the standard reduction potential for cadmium. Okay, standard hydrogen electrode means that the standard reduction potential for hydrogen is equals to 0. Okay, so this one you must know. So from here, you will know that E cell, this is a revision, equals to E naught cathode minus E naught anode. our cathode will be 0. Okay, this one is 0. Then our cadmium is minus negative 0.40. Okay, now we go to the next one. Okay, if you are asked to calculate the equilibrium constant when E cell equals to 0. Okay, now same thing again. Determine which one is anode and which one is cathode. Okay, I just choose one of them. For example, I choose chromium 0, positive 3. So number of oxidation number increase, so it is anode. Okay, then after that, get the overall cell equation and then start to write the E cell equals to the Nernst equation, E naught cell minus 0.0592. Okay, how many electrons do we need? Here we have 3, here we have 2. So meaning that we will need to multiply by 2, here multiply by 3. So we will get 6 electrons. Okay, product solid. So we just need Cr 3 positive square and Sn 2 positive power of 3. Okay, and then remember, because you are looking for equilibrium constant, so there's a very important keyword that you need to write, that is E cell equals to 0 volt at equilibrium. Okay, therefore your E cell equals to E naught cell minus 0.0592 over 6 log K. So you just need to find out what is your K. Okay, now next one. We go for how to calculate the concentration or partial pressure of a species. Okay, let's say you are given a cell notation. Okay, so for cell notation, we know that on the left it is anode, on the right it is cathode. Okay, then after that, balance the equation, okay, to see which one do we need to put into the Nernst equation. Okay, solid, no need. So our E cell equals to E naught cell minus 0.0592 to log. So product is Fe2 plus Cl minus, and because chlorine is gas, so it is BCl2. Okay, then after that, you just substitute the information into the Nernst equation, then you shall find out what is the partial pressure of chlorine. Okay, another one is, after you find the concentration, you can actually find the pH of the solution. Okay, let's look at here. It says here that the pH of the HCl solution, asked to find the HCl pH. Okay, then given we have Al3 positive, we also given pressure, and then okay, Daniel cell is also galvanic cell, and already given the E cell. Okay, EMF is the E cell because not extended condition, and then you need to balance. Okay, you need to balance the equation. Okay, then you just write down E cell equals to E naught cell minus 0.0592. Okay, again, look at the electron. So means that we need to multiply by 2, multiply by 3. So we will get again 6. Log, okay, let's look at the product. Solid, no need. So we will get aluminium 3 positive, aluminium 3 positive, square, okay, hydrogen gas, power of 3, and then hydrogen ion, power of 6. Okay, so we find out what is the concentration for pH for hydrogen first. Then we can find negative log H plus. So we will get 0.6 for the pH of solution. So when you look at all these four calculations, you can calculate cell potential, equilibrium constant, concentration or partial pressure, or pH. But remember, the first step you always do is make sure you get the number of electron correct. You balance the overall cell equation from anode and cathode. Okay, only then you substitute into the Nernst equation. Then look at what are the information given. Okay, so that's all for this part.